Welcome. This is the Regression Analysis course. My name is Nicola da Serba. I'm an associate professor in the Stewart School of Industrial System Engineering. The lecture is Multiple Linear Regression, illustrated with examples. In this lesson, we'll illustrate multiple linear regression with the prediction of IMDb moving ratings. In this lesson, I will introduce this example along with exploratory analysis based on visual analytics and numerical summaries for both quantitative and qualitative variables. The Internet Movie Database, or shortly IMDb, is the most used website to access comprehensive information for movies and TV content. With over 65 million registered users, it remains one of the most trustable sources of data. It allows users to submit ratings and reviews. The most popular feature of the site is its movie ratings, being heavily influenced by the number of people watching movies on the screen or rent out DVDs. Analyzing the IMDb ratings, particularly identifying the factors predicting the ratings, has been a popular problem over the past couple of years. The source of the data is the IMDb's website. The response variable in this example is the rating provided by the IMDb, scaled with values between 0 to 100. The website provides many different qualitative and quantitative predicting variables. I selected the most relevant ones. Among the quantitative variables, including this analysis, include number of votes for the movie on the IMDb platform, duration of the movie, gross earnings scaled in thousands, and total budget in million. Several qualitative variables are also considered, including release year, rating of movies' suitability for certain audience based on its content, language, genre, director rating, actor rating, movie awards. I considered year as a qualitative variable since we have only few years of data. In the case when there would be more years, then this could be considered as a quantitative variable. Generally, when a predictive variable is not very granularly observed, like year in this case, it can be transformed into a qualitative variable. This slide shows the data processing of the quantitative variables. We begin with reading the data from the file training.csv, which includes a header, and the separator between observations is comma. For this example, I consider only a subset of the movies available on the IMDb website, only 100 movies. To have a rating between 0 and 100, I multiply the response data values with 10. Furthermore, I extracted the qualitative variables from the data matrix using the $sign. I then created a data frame which is used to obtain the scatter plot matrix of the response variable and the 4 predicting variables. This is the scatter plot matrix, and what I'm presenting here on the first row are the scatter plots of the response variable, the IMDb ratings, versus the 4 predicting variables, along with the scatter plots of pairs of the predicting variables. There's some clear patterns of the relationship between the IMDb ratings and the predicting variables. There is a strong relation between rating and number of votes. There's also a weak relationship with duration of the movie. There are some correlation among the predicting variables, for example, between the number of votes and duration, and between earnings and total budget, as actually expected. Processing the quality variables is more work. As you can see, the line of code, the code in for R is long. First, if the variables are coded numerically rather than their descriptive labels, I recommend to use the descriptive labels. This is what I did on this for this R code. For example, for genre, the variable is coded with numerical values 1 to 4. But I replaced this labeling with a description of the genre, including action, documentary, comedy, and or science fiction. If you want to explore whether these quantitative variables explain some of the variability in the response variable, you can use a side-by-side box plot similar to the analysis of variance, to ANOVA. We compare the variability of the response variable across the labels of each of these qualitative variables. The box plot commands of this slide do just that. To review, for better visual analytics and reference, remember to inform the quantitative variables using their specific class or label names, rather than numeric or other less meaningful labeling. Second, do not forget to transform each one of it into a categorical variable using the factor command in R. These are important first steps in dealing with qualitative variables. Here are the box plots for 6 qualitative variables in our analysis. The response variable does vary with year and the award number of directors. There is less between group variability with respect to other predicting factors. We can complement the visual analytics with numerical summaries of the data. For qualitative variables, we can use the correlation analysis. The COR or core command in R can be used for obtaining the correlation coefficients for multiple factors for multiple variables by using a matrix as an input in this command. I use here the command round so that I only output the correlation coefficients with only 2 digits. As pointed out before, there is a linear correlation between rating and number of votes and between rating and the duration of the movie. There is also a strong linear correlation between earnings and total budget for the movie production. For numerical summaries between the response and individual qualitative predicting variables, we can use the ANOVA to test whether the means in the response are statistically different across the categories of the quantitative variable. For example, the p-value for equal means of the rating across years is small, suggesting that the means of the IMDb ratings are statistically significantly different across years, and thus a difference in rating can be to the release year of the movie. For numerical summaries between any two qualitative predicting variables, we can use the table command in R, which gives us the number of observations by groups. For example, there are 13 movies in our sample with both movie and director awards, but there are 10 movies where the director was nominated but not awarded and the movie was awarded. To quantify statistically whether there are differences across the proportions, there are differences in the proportion across the sales in this table, we can use the so-called chi-square test. For this example, the p-value of the test for the 2 categorical variables is very small, indicating that there are differences in the proportion across the cells in the table. In summary, if we use the correlation coefficient to evaluate the relationship between 2 quantitative variables, we need to keep in mind that the correlation coefficient only quantifies linear dependence, linear relationships. To evaluate whether a qualitative variable has explanatory power for the response variable, we can use the simple ANOVA model. Moreover, we can also evaluate the relationship between any 2 qualitative variables using the table command and the Pearson chi-square test. To summarize, in this lesson, I illustrated exploratory data analysis for both quantitative and qualitative variables within a specific example. In an example, we're interested in the prediction of the IMDb ratings. Thank you.